Imagine a computer so powerful it makes our current technology look like toys. That's the promise of quantum computing. It's a whole new way of processing information. It taps into the strange and fascinating world of quantum mechanics. Quantum computing has the potential to revolutionize entire industries. From medicine to materials science, the possibilities are mind-boggling. We're talking about developing life-saving drugs. We could design entirely new materials with unheard-of properties. But to understand its power, we need to take a peek behind the curtain. We need to explore the fundamental principles that make quantum computing so revolutionary. Our everyday computers rely on bits. A bit is like a light switch. It can be either on, 1, or off, 0. But quantum computers use qubits. Think of a qubit as a dimmer switch. It can be on, off, or somewhere in between. This in-between state is called superposition. It's like a coin spinning in the air before it lands on heads or tails. This allows quantum computers to perform many calculations simultaneously. It's like having millions of computers working together on a single problem. Qubits have another trick up their sleeve: entanglement. When two qubits are entangled, they become linked, sharing a secret connection. This interconnectedness is where the true power of quantum computing lies. It allows for incredibly complex calculations. This opens up doors to solving problems that are impossible for even the most powerful classical computers. We're talking about cracking the codes that protect our online information. We're talking about designing new materials at the atomic level. Quantum computing is still in its early stages, but its potential is undeniable. It's a journey into the heart of the quantum world. Imagine the quantum world as a vast playground, filled with subatomic particles like electrons and photons. These particles are the building blocks of everything around us. They behave differently than objects in our everyday world, governed by the laws of quantum mechanics. An electron, for instance, doesn't just exist in one place. It's more like a fuzzy cloud of possibilities, smeared out across space. It's only when we try to measure its position that it collapses into a definite state. This uncertainty is fundamental to the quantum world. This mind-bending concept is what makes quantum computing so powerful. Think of a coin standing on its edge, representing both heads and tails simultaneously. Now, let's introduce two kids into this quantum playground, each holding one of those spinning coins. These coins represent our entangled qubits. When these qubits become entangled, it's like tying an invisible string between the two coins. If one coin falls on heads, the other instantly falls on tails, no matter how far apart they are. This instant connection, this spooky action at a distance as Einstein called it, is what makes entanglement so fascinating and powerful. Imagine the possibilities. It's like having two interconnected computers that can share information instantly, regardless of distance. Entanglement is a key resource for quantum computers, allowing them to perform computations in ways that classical computers simply cannot. It's like having a shortcut through the fabric of reality. Now, let's add more kids and more coins to our quantum playground. As we introduce more qubits, the number of possible states they can represent increases exponentially. It becomes a complex and beautiful symphony of superposition. This massive computational space is where quantum computers truly shine. They can explore countless possibilities simultaneously, like trying every key on a giant piano at once to find the perfect melody. Whether it's breaking complex codes, designing new materials, or simulating intricate biological processes, quantum computers offer a whole new realm of possibilities. This is the power of quantum computing, to harness the strangeness of the quantum world and turn it into a tool to solve some of humanity's greatest challenges. Think about how we solve problems in the classical world. It's like flipping a series of light switches on or off. Each switch represents a bit, a tiny piece of information. Want to add two numbers? Flip the switches in a specific sequence. Want to store a picture? Use millions of switches to represent each pixel. But this light switch approach has limitations. Imagine searching for a specific grain of sand on a beach. A classical computer would have to examine each grain one by one, a tedious and time-consuming process. Quantum computers, however, take a different approach. They're less like light switches and more like dimmer switches. Instead of just on or off, they can exist in a blend of both states simultaneously. This parallelism gives them a significant speed advantage for specific types of problems. Imagine trying to juggle hundreds of tennis balls. That's the challenge facing classical computers dealing with complex problems. Each ball represents a variable, and keeping track of them all becomes a juggling act. Now imagine those tennis balls are shadows. A quantum computer doesn't juggle the shadows themselves, but manipulates the object casting them. By subtly shifting the object, it influences all the shadows at once. This is akin to how entanglement works. By linking qubits, we create a network of interconnected shadows. Changing one qubit instantly affects the others, no matter how far apart they are. Classical computers often rely on brute force. They try every possible solution until they stumble upon the right one. It's like trying every key on a giant keyring to find the one that unlocks a door. Quantum computers, through entanglement, can feel the solution in a way. They don't have to check every possibility individually. This elegance stems from the interconnectedness of qubits. They don't exist in isolation, but work together, their fates intertwined. This allows them to explore a problem's solution space more efficiently. The shift from bits to qubits might seem subtle, but it's like comparing a single star to the vastness of the cosmos. It's a fundamental change in how we process information. Classical computing is like navigating a city with a grid system, logical and predictable. Quantum computing is like sailing uncharted waters, guided by the stars and the ebb and flow of the tide. It's a realm where uncertainty isn't a hindrance but a powerful resource. This shift requires a new way of thinking, a new set of tools and algorithms. The transition to a quantum-powered world won't happen overnight, but understanding the profound difference between bits and qubits is the first step in unlocking the incredible potential of this revolutionary technology. Imagine a world where developing life-saving drugs is as quick as snapping your fingers. That's the potential of quantum computing in medicine. It's like having a key that unlocks the secrets of molecules, those tiny building blocks of life itself. Today, designing new drugs is a long and costly process. Quantum computers could change that. They could simulate the behavior of molecules with incredible precision. This would allow scientists to see how drugs interact with the body at the atomic level. Instead of testing thousands of compounds in a lab, scientists could use quantum computers to simulate their effects. This would speed up drug discovery dramatically. Quantum computers could also revolutionize personalized medicine. They could analyze an individual's genetic makeup and predict their response to different treatments. Our world is full of complex systems. Think of the global supply chain. It's a tangled web of routes, schedules, and deliveries. Even a small disruption can cause chaos. Quantum computers excel at optimization problems like these. They're like master puzzle solvers, finding the most efficient way to untangle even the most complex knots. Imagine using quantum computers to manage air traffic control. They could optimize flight paths in real time, reducing delays and saving fuel. Or consider traffic in our cities. Quantum computers could analyze traffic patterns and adjust traffic lights dynamically. This would ease congestion and reduce travel times. The applications go beyond transportation, optimizing energy grids and tackling climate change. We live in a digital age. Our personal information, financial transactions, and national security all rely on encryption. But what if our current encryption methods are vulnerable? What if someone, somewhere, is building a computer powerful enough to crack our codes? That's where quantum computing comes in, both as a threat and a solution. Quantum computers could potentially break the encryption algorithms we use today, but they also offer a path to even stronger encryption methods, quantum cryptography. Imagine a world where communication is truly unhackable. It uses the principles of quantum mechanics to create encryption keys that are impossible to copy or intercept. Quantum-resistant encryption is essential for a secure digital future. The universe is full of mysteries. From the nature of dark matter to the origins of the universe itself, there's so much we don't know. Our current telescopes, powerful as they are, can only see so far. Quantum computers could change that. They could act as quantum telescopes, allowing us to see the universe in entirely new ways. For example, they could help us detect gravitational waves, ripples in the fabric of space-time caused by some of the most violent events in the universe. These waves carry information about black holes, neutron stars, and the early universe. Quantum computers could enhance these instruments, making them even more sensitive to these faint cosmic whispers. Quantum computers could also help us understand dark matter, the mysterious substance that makes up most of the matter in the universe. By harnessing the power of the quantum world, we can push the boundaries of knowledge and unlock the secrets of the cosmos. The quantum world, with all its wonder and potential, is a delicate place. Imagine a tightrope stretched across a vast chasm. That's the challenge of building and operating a quantum computer. Qubits, those fickle building blocks, are incredibly sensitive. The slightest disturbance, a stray electromagnetic field, a tiny vibration, even a change in temperature, can knock them out of their delicate superposition. This sensitivity makes quantum computers incredibly difficult to build and maintain. We need to create environments that are shielded from all forms of interference. And even then, maintaining the coherence of qubits is a constant battle against the forces of decoherence. Imagine trying to tame a wild beast, brimming with power but prone to unpredictable bursts of energy. That's the challenge of developing quantum algorithms, the instructions that tell quantum computers what to do. Classical algorithms, the ones that power our everyday computers, are like well-worn paths through a forest. But quantum algorithms are more like charting a course through uncharted territory. We need new ways of thinking, new mathematical frameworks to harness the power of superposition and entanglement. It's like learning a new language, one that speaks in probabilities and quantum logic gates. This is where the ingenuity of computer scientists and physicists collide, working in tandem to decipher the language of the quantum world. Section 3. A future forged in uncertainty. The path to a quantum-powered future is not a straight line. It's a winding road with many forks and detours, filled with challenges that seem insurmountable. But like any great journey of discovery, the thrill lies in the pursuit of the unknown. We're still in the early days of quantum computing. It's like the early days of flight, when the Wright brothers first took to the skies. Back then, few could have imagined a world with supersonic jets and space travel. Similarly, the full impact of quantum computing on our world is still unfolding. But one thing is certain: it has the potential to be just as transformative as the invention of the airplane, the computer, or the internet. It's a future where the impossible becomes possible, where the limits of our current technology are shattered, and where the answers to some of humanity's most pressing questions lie within reach. Section 1. The dawn of a quantum era. We stand on the precipice of a new technological epoch. The quantum revolution is not merely on the horizon, it's already here. Like the first faint glow of sunrise, its light is beginning to illuminate the landscape of our future. It's easy to dismiss quantum computing as something out of science fiction, a realm of complex equations and mind-bending concepts. But the truth is, we're already witnessing its impact. From optimizing logistics to developing new materials, quantum algorithms are quietly transforming industries behind the scenes. This is not a future reserved for elite scientists or tech giants. It's a future that will touch every aspect of our lives, from healthcare to finance, from communication to entertainment. Imagine a world where traffic jams are a distant memory, where diseases are diagnosed and treated with unparalleled precision, where the energy crisis is a relic of the past. This is the promise of the quantum era, a future where the limitations of our current technology fade away, replaced by a world of possibilities that were once deemed unimaginable. Section 2. Embracing the quantum revolution. The quantum revolution is not something to be feared or resisted. It's an opportunity to reshape our world for the better, to address challenges that have plagued humanity for centuries. But this transformation won't happen overnight. It requires a collective effort, a willingness to embrace the unknown and push the boundaries of human ingenuity. We need to invest in research and development, to nurture the next generation of quantum pioneers. We need to foster collaboration between academia, industry, and governments, breaking down silos and encouraging the free exchange of ideas. Most importantly, we need to cultivate a sense of wonder and curiosity to inspire the next generation to explore the quantum realm and unlock its secrets. Just as we once looked up at the stars and dreamed of space travel, we must now look inward to the heart of matter itself and imagine the possibilities that await us. The quantum revolution is not merely about building faster computers or developing new technologies, it's about expanding our understanding of the universe and our place within it. It's about embracing uncertainty, not as a limitation, but as a source of infinite potential. It's about daring to dream bigger, to imagine a future where the impossible is within reach.